Well, hello again. Welcome to my continuing quest to look like I know what I'm doing. Last week, we talked about magnets, and this day, we're talking about electromagnets. The first thing we're going to do is talk about how electricity produces magnetism. We are going to be taking this compass and this wire, this little battery. First, we're going to wrap the test lead around the compass as shown in picture 1, using a small piece of tape to keep it together. Now, in the test, we're going to be doing it with the battery set twice. So one will do it like this and one will just switch them. And I predict that what's going to happen is that whatever direction the needle points in the first trial, it will point in the reverse for the second trial, which just seems to make sense. The point of having the bulb in the thing is so that we don't make a short circuit, because that would be bad. Now, we will place this here. We are doing this with one of the D batteries. Well, it's definitely not pointing in the right direction. The needle, it's going mostly perpendicular to the wire, but it's a slight angle so that the north needle is pointed towards the negative side, and the south one is pointed slightly towards the positive side. Now, I am going to switch it, and I predict that, again, the north one will be slightly towards the negative, and the south will be slightly towards the positive. And it's working because electric fields and magnetic fields are deeply linked. They're perpendicular. They are perpendicular to each other, which is why it's making the electric field. Yes! And it's more perpendicular this time. At a 45-degree angle. With the positive side, like, the wire is going across the north and south line, and the north needle is pointed northwest, and the south needle is pointed southeast. I predict it's user error. I think this is user error. I think this was supposed to be more perpendicular. The reason that it moved is that with the electric field is making a the electric field is making a perpendicular magnetic field, and that is affecting the compass, because that's what the compass is attracted to, magnetic fields. That's why right now it's pointing north, because that's the direction of the pole of the biggest magnetic field around. Next, we are going to talk about how magnetism produces electricity. So what we need is magnet. Well, we're going to set my multimeter to record current 2000, what is that, am I putting it? Now hold the wire and the magnet still. Oh, of course. Nothing happens, which makes sense. So hold the wire still and move the magnet back and forth across a perpendicular line. Oh, a perpendicular line. Right, because we're trying to make an electric field perpendicular. Ooh, we're getting 1, 2, 3. Let's just try faster. Going between 1 and 3. Now hold the magnet still and move the wire back and forth. Ooh, it's going up faster. 1, 2. It's going between 1 and 2. Now coil the wire as shown. That's just to hold it together. Now move the coiled wire back and forth across the pin to the magnet. No, stop. I'm getting 1s and 2s. 1, 2, 0, 2. 1, 2. 1, 2, 0, 2. Now move the magnet through the coiled wire. 1, 2, 1, 2. Let's try this. 1, 2, 1, 2, 1, 2. Now, build the circuit as shown using different magnets. Run your magnet around top, on bottom, and along the side. You may not be able to move the wire of the magnet. You should be able to feel the resistance to the magnet field where you are. We need to put this to this. Don't want a short circuit. We're going to use different magnets and run them around the wire. I can feel that resistance that it's talking about. So yeah, with those two experiments, we proved that electricity and magnetism are like completely, absolutely, utterly, intrinsically linked. Next is the fun part. Make an electromagnet. Now, we will need electromagnetic wire. Is this what they're talking about? Also need this here. So I'm going to take this and I'm going to sand off 3/4 of an inch of the top of each of them. I want to start making an electromagnet. Sanding is not fun. Take you. And you. And you. Are you magnetic? It's a magnet! See how many paper clips we can lift. There's a bunch. It's not super strong. Let's try it again, but this time with a smaller rod. One. One. I think that one is this one's limit. Now let's wind it back up, all the way up, and see what happens. Awesome. Trying again. I see 2. 2 is the limit this time. Now, I'm just going to use it all. All of the power. Let's try this time. Boom, boom, boom. Let's be careful with this one. Yep, that lifted all of them. Super easy. It's been quite a bit of strength. So now we will make a solenoid. Observe the electricity that is produced from magnetism by doing the following experiment. Cool! I get what we're doing. No. So now what do? Now what do we do? I sand off the end so it can be used in the circuit like so. So what I'm doing is I'm going to be wrapping this around this. Then I'm going to be connecting it to the circuit, which then I'm going to turn on and we're going to see it. It's going to create a magnet, which is going to pull this nail inside. So like it'll be far away and it'll be. Well, but here's the question: will it go and stop, or will it? It's time to see. Connect these in series. Done. Connect one end to my solenoid. Done. So now we're going to do this. It worked! Excellent! Now, don't leave them in the solenoid long. There's no real load on the circuit. But wait. I could use this for my filmmaking. Notice, I asked if it would throw it on the other side or if it would just collect it, and look. It just collects it and then it sits there.